All right, today we are going to tackle a real AQA GCSE chemistry exam question head on. We're going to break down question 4, all about polymers, and I'm going to show you exactly how to think like an examiner so you can bag every single one of those marks. Let's dive right in. So what are we looking at? This is the real deal. It's the AQA GCSE Chemistry Higher Tier Paper 2 from June 2021. And by digging into an actual paper and its mark scheme, we're not just guessing what they want, we're learning the exact rules of the game. Okay, so here's our game plan. First, we'll crack open question 4. We'll hit the basics of polyethylene, then get into explaining polymer properties. After that, we'll look at how polyesters are made, and finally, we'll wrap it all up by mastering that all-important mark scheme. Right, let's get into it. This is your guide to grubbing those maximum marks on a topic that, trust me, comes up all the time: polymers. But before we jump into the actual question, let's have a super quick refresher. What even is a polymer? Well, just think of it like a long chain, kind of like a necklace. Each individual bead on that necklace is a smaller molecule we call a monomer. Simple as that. Okay, with that in our back pocket, we're ready. So, first up, we're going to tackle questions 4.1 and 4.2. These are all about one of the most common addition polymers you're ever going to see, polyethylene. Okay, here's the first task. The question is asking you to complete the equation for how polyethylene is formed from ethene. So you've got N of these little ethene molecules. How do they join up? The big clue, as always, is that double bond. What happens to it? What's going to break to let that chain form? And here it is, the perfect 2-mark answer. You can see that double bond in the ethene has snapped open, right? And that allows it to form single bonds with its neighbors, creating this long repeating unit that we put in brackets with the little n outside. But here's a really cool tip, straight from the mark scheme. Even if you kind of mess up the whole thing, you can still get 1 mark just for drawing the 5 single bonds correctly or for getting the n in the right place. It's like a built-in safety net from the examiner. Okay, next up, we've got more of an application question. See, it's not just about knowing what polyethylene is, you've got to understand its properties. So the question is, why is it recycled? What makes it a good candidate for that? Right, the mark scheme is super clear on this. It's looking for 2 connected ideas. First, you have to say that polyethylene melts. Boom, that's 1 mark. But you are not getting that second mark unless you link it. You have to explain, so what? Well, because it melts, it can be reshaped into new things. It's that melts, so can be reshaped connection that gets you the full 2 marks. Okay, let's keep digging into these polymer properties. Now, this next part of the question is really interesting, actually. It's all about how you can take the exact same monomer and create plastics with totally different characteristics. How cool is that? So, question 4.3 asks, how are low-density and high-density polyethylene produced from the very same monomer? I mean, think about it. It's a great question. You've got one building block, ethene, but somehow you end up with 2 completely different plastics. How on earth is that possible? And you know what? The answer is so simple, it's brilliant. It's all about using different reaction conditions. That's it. For 1 mark, all you have to write is that they use different reaction conditions. Now, if you want to show off a little and be more specific, mentioning different temperatures or different pressures works perfectly too. Okay, on to 4.4. This time, you have to explain why HDPE, that's high-density polyethylene, has a higher density than LDPE. And look, the exam paper actually gives you this diagram, which is a massive clue. Seriously, take a close look at the structures. What's different about how the chains are laid out in HDPE versus LDPE? And here we go. This slide lays out the perfect 2-mark answer. For mark number 1, you just have to say that in HDPE, the polymer chains are way closer together. They're all straight and unbranched, so they can pack in really neatly. Then, for the second mark, you explain what that means. Because they're packed so tightly, you've got more atoms, more stuff, in the same amount of space. It's literally the difference between neatly folding your clothes to pack a suitcase versus just chucking them all in. You can fit more in when it's neat, right? Same idea. All right, time to shift gears. We've been talking about addition polymerization, but now we're going to switch over to condensation polymerization. This next bit of the question is all about how we make polyesters. So question 4.5 is a pretty straightforward identification task. They give you these 3 monomers and just ask you to circle an alcohol functional group. Remember, that's the bit of the molecule that's actually going to do the reacting to make the polyester. And that's it. Simple as that. The mark is just for circling that HO or OH group on monomer A. It's a nice, easy mark waiting for you as long as you know your functional groups. Okay, we're on to the final part of question 4 now. So remember that key difference with condensation polymerization? When the monomers join up, a small molecule gets kicked out. It's lost in the reaction. This question asks you to figure out what that small molecule is for 2 different reactions. So here's the completed table. When A and B react, you get water, H2O. When A and C react, you get hydrogen chloride, HCl. Now listen up, because here comes a classic exam trap, and the mark scheme points it out specifically. Your answers have to be in this exact order. It seems like a tiny detail, doesn't it? But getting the order right shows the examiner you know precisely which reaction produces which byproduct. Get them the wrong way around, and poof, the mark is gone. And there we have it. We've worked our way through the entire question. So what have we actually learnt here? I mean, this isn't just about the chemistry of polymers, is it? It's about learning the strategy, how to turn what's in your brain into actual marks on the paper. So let's recap the key learnings. First, you've got to use precise scientific terms. Words like melts and closer together aren't just suggestions, they're what get you the marks. Second, you need to be solid on both addition and condensation polymerization. Third, recognizing functional groups like OH, absolutely non-negotiable. And finally, you have to pay attention to the little details like when the order of your answers can make or break a question. This is exactly why going through a mark scheme like this is one of the best things you can do to revise. So there you go. We've cracked polymers and we've dissected exactly how to tackle this kind of exam question. You know, this structured approach, it'll work for any topic. So now I'll turn it over to you. What's next on your revision hit list? Thanks for digging into this with me.